Alright, number one, the first thing that we need to do is we need to factor. So we've got x plus 2, x plus 1, x plus 1 over x plus 1, x plus 3. And we can cancel out our x plus 1s, and that whole, or that x plus 1 that factored out, gives us our whole at -1. And then if I plug -1 back into, hold on. Oops, let's do blue. Okay. If I plug -1 back into what's left, so what's left is my x plus 2 and my x plus 3. So if I plug in -1 here, -1 plus 2 will give me 1. -1 plus 3 will give me 2. So I have a hole at -1, 1/2, and I'm going to try to draw a hole as the best I can. Now, my graph is small, so you're going to have to assume that you can see it. It's just really hard to draw it with a pen. Okay, my x-intercepts, I basically set my y value to 0, which is my numerator equal to 0. So you're only going to use what's left, which is the x plus 2 equal to 0. So my x is -2. And remember that they are coordinates, so -2, 0. Right there. Then my y-intercept, you set your x's equal to 0. So I'm going to use what's left. So my x plus 2, So my 0 plus 2 over 0 plus 3 gives me 2/3, 0 2/3. And so that's about right here. It's tiny. Then your vertical asymptotes, you set your denominator equal to 0. And so the only thing that's left is my x plus 3. So I have an asymptote, vertical asymptote at x equals -3. Horizontal asymptote, you take your variables of your coefficients. So I'm going to go back and look at my original equation, and my largest variable, in this case, top and bottom, is x squared. So I'm going to take the coefficients for x squared on top, which is 1. Coefficient for x squared on bottom is 1. So 1 divided by 1 gives me 1. So I have a horizontal at y equals 1. And so there is no slant asymptote. Okay. And my graph, let me find a color I can use. Let's do gray. Okay, so on this one, my graph, white's not going to work. Let's do gray. Here's my graph. I gotta get back to my pen. Gray. Hold on. Okay, here we go. Sorry, I'm trying to get the pen to change colors. And we'll go this way. And if I plug in a value over here, I need to see whether it's going to be on top or it's going to be on bottom. I'm going to plug in -5. And if I plug in -5, I have -5 plus 2 over -5 plus 3. That gives me -3 over -2, which is a positive 3/2, which means that I'm going to have at -5, 3/2 is at 1.5, so that means my graph's going to be in here for the other part. So then for your left and right end behavior, we're going to do blue. So this signifies my right end behavior. This looks at my left end behavior. And so on the left, it's your limit as x approaches -infinity of my function. And this is going towards your asymptote. It should always match, this end behavior here will always match what that number is if you have an asymptote. So 0. Oh, no, sorry, not 0. Sorry, my asymptote's 1. And then, let's erase that alone. And then for my right end behavior over here, this one also is going towards 1. So my limit as x approaches infinity of f of x equals 1 also. All right, number 2, again, we need a factor. X squared minus 9 turns into x minus 3, x plus 3, difference of squares. over x minus 2. Nothing cancels on this, so since there's no term that cancels, we have no holes. My x-intercepts, you're going to set your numerator equal to 0, and since we have 2 of them, x minus 3 equals 0, x plus 3 equals 0, we're going to get x equals 3, x equals negative 3. So that's going to be, oops, let me move this over. 3, 0, negative 3, 0. And then for y-intercept, you set your x is equal to 0. So really it's just going to end up being your 9 halves, 0, 9 halves. Oh, let me go and draw in. So my intercepts at negative 3, 0, positive 3, 0. And then my y-intercepts at 0, 9 halves, so that's 0, 4 and a half up here. My vertical asymptote, set your denominator equal to 0. So that's going to be x equals 2. That's a vertical line. So that's this one. 2 for my vertical line. And then black, horizontal. Now on horizontal, we're going to go back to the original. Hold on, I'm going to erase. Oh, actually, I can't erase that one. Okay, so anyway, so you're going to go back to your original, and you're going to look for your largest variable. So my largest variable here is x squared. So my largest variable is going to be x squared. So I'm looking for x squared in the numerator and denominator. In the numerator, my x squared coefficient is 1. I have no x squared in the denominator, so that's 0. So 1 over 0 is undefined, so I don't have one. So therefore I have a slant, and for this one I need to use longer synthetic division. And since this is x minus x plus, I'm going to use synthetic division for my slant asymptote. Let's do lunch. And since I have x squared minus 9, that's x squared plus 0x minus 9. So I do a 1, a 0, a negative 9. And then my x minus 2 gives me a 0 of 2. Or it gives me a value to use of 2. So then bring down the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 5. And remember, we don't need our remainder. All we need is this. This is my coefficient for x. This is my constant term. So my slant is going to be y equals x plus 2. So I'm going to put a y-intercept at 2. Slope of 1, up 1 over 1. There's my slant asymptote. And I already have points in my graph, so I'm going to have 1 here, 1 over here on this side. And for my right and left end behavior, here's my right end behavior, here's my left end behavior. So on my right end behavior, my limit as x goes to, my left end behavior, limit as x goes to negative infinity, it's getting smaller and smaller and smaller, so it's going to negative infinity. On my right hand side, as my x's are getting bigger, my y's are also getting bigger. So my limit as x approaches positive infinity of f of x is positive infinity. So when you have a slant asymptote and you don't have a horizontal asymptote, these are going to go to infinity or negative infinity, depending on which way it goes. Number 3. So again, factor. So we've got x and x. So we've got 2 and 1, and I need a positive 2 and a negative 1. So again, nothing cancels. It is going to give us some other asymptotes. Hold on, I got to change colors. Okay, so for holes, there's none. X-intercepts, we've got from these, x-intercept at negative 2, x-intercept at 1, so 2, 0, 1, 0. Oh, sorry, negative 2, 0, 1, 0. Negative 2, 0, 1, 0. Those are my x-intercepts. Basically, that when you set your numerator equal to 0, please make sure you remember those for the test. For your y-intercept, oops, let me change colors. You are going to set your x is equal to 0, which is going to give me negative 2 over negative 2, which gives me 1. So I have one at 0, 1. Vertical asymptotes, you set your denominator equal to 0. So my denominator equal to 0, x minus 2 equals 0 is, oops, actually, let me move it over here. X minus 2 equals 0, x equals 2, x equals 2. Vertical line here. Horizontal, again, we're going to go back to the original right here. Coefficient is 1 on top, or my largest variable is x squared. Coefficient on top for x squared is 1. Coefficient for x squared on bottom is 0. So I don't have an x squared, so you're looking at x squared, sorry, on top and bottom. So there is none, which means this is going to be similar to the last one, where we have synthetic division, and you always do synthetic division on the original. So we've got 1, 1, negative 2, and that's an x minus 2, so we're going to put a 2 on the outside and do our synthetic division. 1, 2, 3, 6, 4, but remember we don't need our remainder. All we need is our constant term and our x. So that's y equals x plus 3. So 1, 2, 3. There's my slant asymptote. And this time we have a graph already in here. And now I need to find whether it's up here or down here. And so I'm going to try, say for example, 1, 2, I'm going to try 3. So if I plug in 3, I'm going to get 5 times 2 over 1. That's 10. So 3, 10. 4 would be 6, 3, 2. So that would be 9. So you're going to end up being in here. And again, it doesn't need to be exact. Just get a few points just to make a general graph. Then for your end behaviors, oops. Here's my right end behavior. Here's my left end behavior. Kind of similar to the last one. My limit as x approaches negative infinity. My y values are getting smaller and smaller, so it's going to negative infinity. Whereas on the right, as my x's are getting bigger, my y's are getting bigger. My limit as x approaches positive infinity of f of x is positive infinity. Okay, number 4, we're kind of going backwards. So I'm going to draw on our picture everything that we have. We have intercepts at, oops, let me make them a different color. Let's make them red. Intercepts at 0, 0. I have vertical asymptotes at 2. And you don't have to draw on the graph. This is just to help you, unless I tell you to draw on the graph. There's my vertical and a horizontal at 3. Okay, so in writing my equation, remember your vertical asymptotes you got from setting your denominator equal to 0. So if I start with that, the 2 will turn into x minus 2. The x minus 2 will turn into x plus 2. And then that itself will be x squared minus 4, eventually. I have a point at 0, 0, so I'll deal with that part later. Let me change my colors. So if I have an x squared on bottom, if I have a horizontal asymptote on top, basically if there's an x squared here, there needs to be an x squared here, because that's the only way that you're going to get a number. If they don't match and one's an x or an x cubed and they're different degrees, then you're either going to get 0 or undefined. So in order to get an x cubed, I have to at least put in an x squared up here. But in order to make this a horizontal at 3, I need to have a ratio of 3 to 1. So I can either have 3 on the top, 1 on bottom. I could have 6 on top, 2 on bottom. Make sure if you do 6 on top, 2 on bottom that you put a parentheses around it. And you can kind of double check. As long as I have any number up here, setting this equal to 0 will get me my intercept at 0 for this. So for my x squared, I just need to have a 3 in the front. And so my equation is just 3x squared over x squared minus 4. I don't care whether you leave it in this form or in the factored form for that. So you know you're going to have part of your graph in here. And then if I check the number 5 in this, so 3 times 5 squared, whether I do 5 or negative 5, I'm going to get the same thing. And so 3 times 5 squared, that is 25 times 3 is 75 over 5 squared minus 4. 25 minus 4 is 21. So 75 divided by 21 is going to be a little more than 3. So I know that these have to be basically in here, up here. Then for my end behavior, there's my right end behavior, my left. I don't need to worry about this in here. When you get to calculus, you're basically going to talk about your limit as x approaches 2 from the left, and this one you'll talk about it as x approaches negative 2 from the right. But right now all we're concerned about is the ends, and so my limit as x approaches, oh, let me make my pencil thinner. X approaches negative infinity of f of x equals, again, you have a horizontal asymptote, so it's going to go to 3. Okay, so on 5, the first thing that we're going to have to do is we're going to have to factor this. So I'm going to do the top first in blue. I'll do the top over here. We're going to factor it first. So since we have synthetic division, I need all the factors of 8. So I'm going to try 1, 2, 4, and 8 with synthetic division. And all I need to find is 1. So let's say I try 4. It gives me 1, 4, 1, 4, negative 2, negative 8, 0. So I did find 1, and I'm left with x squared plus x minus 2, which factors to, let's see, x plus 2 minus 1, and then the 4 turns into x plus, oops, sorry, not plus, x minus 4. So there's my top. That's the top one. Now we're going to do the bottom one. Now you notice on the bottom they have an x. You need to take the x out first. So x cubed minus 5x squared plus 2x plus 8. I'm going to do the same thing again. All my factors of 8 divided by all my factors of 1. So plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. And then I'll come back and I'll tackle the 0 part later. So my suggestion is to look over here, because chances are I want something on these to cancel. So I'm going to try one of these first. I can either try a 4, I can try a negative 2, or I can try a 1. And one or more of them might cancel. So 1, oops, 1, negative 5, 2, 8. Let's try 4. We tried 4 and it worked before. 4, negative 2, negative 8, and that does work. So I'm left with x squared minus x minus 2. That's x minus 2, x plus 1. And then this is x minus 4. But you also have the x. So I'm going to basically take these factors on the next screen and do all of our math. But we needed to do all the factoring first, and I wanted to do that separately on a screen. Okay, so let me expand this a little bit bigger. Hopefully we have enough room. Okay, so for our holes, we have an x minus 4 that cancels, and I plug in 4. And when I substitute 4 back into here, 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 and here, we're going to get 4 plus 2 is 6. 4 minus 1 is 3. 4, 2, 5. 2 goes into 6 3 times, so I get 9/20. So at 4 and about a half, I get a hole. So I'm trying to draw the hole the best I can on there. My x-intercepts, set your numerators equal to 0. So I have 1 at negative 2, 0. 1, 0. Negative 2, 0. 1, 0. My y-intercept, pick another color, you set your x's equal to 0. So I'm going to get 2 times negative 1 over 0 times negative 2 times negative 1. And since I have a 0 on the bottom, I'm not going to have any y-intercepts. Vertical asymptotes, I get by setting my denominators equal to 0, x equals 0. So that's this line right here. X equals 2, which is this vertical line right here. And x equals negative 1 right here. Okay, so for my horizontal asymptote, I'm going to get, let me change the color. This was originally an x cubed blah 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 over x to the 4th blah blah blah. So my largest variable is x to the 4th. So that's going to be 0 over 1, which is 0. So you're going to have intercepts that go through asymptotes, which means your graph is going to cross. And so I'm either going to go above the line, below, and down, or I'm going to be underneath it. And the asymptote is here, so once I cross this, it's basically going to suction back to the asymptote and go up. In here, since I have boundaries in here between 0 and negative 1, I'm going to have a U shape in here. And here, since I have an asymptote on the middle, it's going to kind of go through like a cubic. So I have to figure out whether it goes from the bottom left to the upper right, or the upper left to the bottom right. And this one over here, we should be able to already draw, because we have this over here. Oops, we should still have a hole there, over here. So, no slant. So now, and I talked about this with 5th period, I didn't get to it in 1st period. Since this is on 0, really I need to figure out whether or not this onto the left of that intercept, it's underneath or above the graph. And since this is at 0, it's real easy just to do a sign graph, figure out whether it's positive or negative. And same thing in here. Then check at negative 1.5 and see whether it's positive or negative. Check at negative 1/2, check at 1/2, and check at 1.5. So we're going to kind of do this. So if I look at negative 5, okay, that's negative 5 here, okay, I'm going to kind of do a sign chart. Now I don't know if I can erase that. So if I plug in negative 5 here, that gives me a negative number. If I plug in negative 5 here, that gives me a negative number. So I end up with a negative and a negative. On the bottom, if I plug in a negative, I have a negative. If I plug in a negative 5, I have a negative number here, a negative number here, and a negative number here. Because all I'm really concerned about is whether the number comes out positive or negative. So I know whether it's above and then it goes below, or whether it's below then it goes above. So I'm really just concerned with the sign of the number. I don't necessarily need to find the exact point because it's probably going to be a pretty ugly number. So again, if I plug in negative 5 here, this is a negative number. Negative 5 gives me a negative number. Negative 5 gives me a negative number. So I end up with 3 negatives on the bottom. And that gives me a positive over a negative, which is a negative. So it means my graph goes below here. And it should go up. So since it's going underneath here, it should go up, but I'm going to prove to you that once it hits it, it's not going to go back down. So I'm going to prove that it goes up to you here. And so this right in between here, I'm going to try the number negative 1.5 because that's in between these 2 points. And negative 1.5 should yield me something that's a positive number. So we're going to try negative 1.5. Hold on. Negative 1.5. So if I plug in a negative 1.5 here, negative 1.5 plus 2 is positive. If I plug in negative 1.5 here, that's negative. If I plug in negative 1.5 here, that's negative. Negative 1.5 here, that's negative. Negative 1.5 here, that's negative. So that's 3 negatives. So I end up with a negative over a negative, which is a positive. So I know that it goes up through there. through that point. Now I have to check and see whether or not what's going to be in this little skinny area right here. Since I have this boundary here, here, and here, it's going to be U-shaped in here. And I'm not concerned with you finding specific points. I just want you to find me a general shape for it. So if I plug in -1/2, so I'm going to do -1/2. Oops. Hold on. I didn't mean to move that. Okay. So if I plug in -1/2, -1/2 here gives me a positive number. -1/2 here gives me a negative number. So I end up with a positive and a negative. And then -1/2 here gives me a negative number. -1/2 here gives me a negative number. If I plug in -1/2 here, I'm going to get a positive number. So I end up with negative, negative, positive. So I end up with a negative over a positive, which is a negative. So I'm going to end up with a U shape in here somewhere. And then over here, since I have another intercept that crosses, I need to see whether it's going to go through this way or whether it's going to start in the upper left and go to the right. So I'm going to plug in +1/2, and that will tell me in this general area whether I'm down or whether I'm up. And since I'm running out of room, I'm going to have to put +1/2 up here. So if I plug in +1/2, I get a positive number. If I plug in +1/2, I get a negative number. So that gives me positive and negative. +1/2 is positive. If I plug in +1/2 here, that's negative. And if I plug in +1/2 here, that's positive. So it gives me a negative over a negative, which is a positive. So my graph is going to go this way in here. So that is my, and then the same thing, just for time's sake, if I did the same thing here, if I plugged in 1.5, I'm going to get a negative value on here. So you can go ahead and plug in 1.5 if you want to check to see that I'm going in the right direction. Then for my end behavior, again, since I have an asymptote, my right and left end behavior is all going to go towards 0. So my limit as my x approaches -infinity of f of x goes to 0. My limit as x approaches infinity of f of x also goes to 0. Okay, last one. So let's factor this one. So my x squared minus 4 factors to x minus 2. Hold on. X plus 2. And then this one I can do with longer synthetic division, or this one should be easy enough that I can do factoring by grouping. X squared plus x, x cubed plus x squared minus 4x minus 4. I can group. Take out, this is x squared, x plus 1. Take out a -4, I get x plus 1. Here is one term. Here is another term. So I have x squared minus 4 times x plus 1. But that x squared minus 4, again, factors to x minus 2, x plus 2, x plus 1. So all of these cancel, and you have to be careful when everything cancels out up here. You have to put a 1 in the numerator to hold its place. So really what's left is x1 over x plus 1 with 2 holes. So I have a hole at 2 something and a hole at -2 something, and I'm going to plug 2 and -2 into what's left. So if I have 1 over 2 plus 1, that's 1/3. 1 over -2 plus 1, that's -1. So I have a hole at 2 1/3. I'm going to draw it the best I can. -2, -1, I'll have a hole. My x-intercepts come from your numerator equal to 0. Now you're going back to this condensed one, not the original. And you can't set 1 equal to 0. So that's something you need to be careful about. If I set 1 equal to 0, that doesn't make any sense. It's not possible. The only time you're going to have an intercept is if there's a variable up here. If it's a number, you don't have an x-intercept. Then for my y-intercept, you're going to set your x values equal to 0, which means you're basically going to get -4 over -4, which will give you 0, 1. Vertical asymptote, now you have what's left in your denominator. So that'll be x equals -1. I'm going to go back to the original for my horizontal asymptote, and if I look at all of this, my largest variable is x cubed. So you look at x cubed, and my coefficient for x cubed on top is 0. My coefficient for x cubed on bottom is 1. So 0 over 1 is 0. So you have a horizontal right here, and you have no slant asymptote. And so you have enough points in here and holes to draw your graph. And again, my end behaviors match my limit as x approaches -infinity on the left of my function is 0, and my right end behavior, my limit as x approaches infinity of f of x equals 0.